Hello, everyone. My name is Serra. I'm a senior DevOps engineer at Invert XGeeks, and today I'm going to talk with you a bit about a project that I've been working for the last 2 years about CI/CD setups, and scalability of them, and more focus on GitLab runners. So let's start directly with the problem or the starting point, what we faced when we enter this project. Imagine that you are a DevOps engineer that makes part of a DevOps team, and one of your responsibilities is to manage GitLab runners to accommodate your team's workloads or pipelines. And you receive one requirement or one request saying from team A saying privilege mode is required to support system calls in our workflows. And you set up a runner specific for this use case, right? Privilege modes, probably it means that it requires some sudo permissions, so you want to keep it isolated, so you will set up a new runner. Next day, you receive another request from another team saying Windows-based high-resource machines. And these two setups are pretty different, so probably you will set up a new runner. Next week, Team C comes to you saying our project requires specific tools and versions to be compiled. And this, once again, this requirement or this request is pretty different from the previous one. So you will set up a new runner setup, or you will manage it, and you will deliver it to the Team C. After, in time, Team X requires Zenzefi server in order to be able to flash our drivers. And you don't even know what Zenzefi server, like me. And so on and so on. Containerization technology, storage in order to cache our dependencies. And all along the time, all these small requirements, these small drops will turn into an ocean of different use cases and different requirements. And managing all these requirements and all these setups turns to be impossible to do. And this was exactly what we faced at the beginning. Having a team dedicated to accommodate so many use cases, it's not feasible. Why? all the challenges all the challenges that we face in traditional. You can think about traditional here as having a team of DevOps that are responsible to manage this entire infrastructure to every single development team. Resource inefficiency. So you will set up these new runners or these new setups. You will implement them with the information that you have nowadays. Might not be that accurate. You can lead into bottlenecks during peak times and so on. Scalability limits. The amount of workloads today might not be exactly the same amount of workload that will be needed tomorrow. Cost overrun. We tend to over provision all the setups. No one wants to be annoyed due to lack of resources, so we usually tend to do a simple, sometimes not so simple margin to accommodate those kind of use cases. And this, especially in the cloud provider, cloud native environments, sorry, it will lead into cost overruns. And at the end, the most important one or the most impacted one is delayed deployment. So at the end, we are delaying or blocking the ability of a team in order to deploy or deliver their workloads. So we knew from the beginning that we will need to create a solution that will be able to accommodate an X amount of use cases. That X might mean 1, 3, or 3,000. We didn't know, and the solution might be able to be flexible enough to accommodate these new use cases that might appear. So, of course, an adaptive solution, possible to know all the use cases up front, cost effectiveness, especially in cloud native environments. This is a very important um, uh, characteristic or requirement to have in mind, because costs can quickly escalate to very big numbers. Configurable by default, so the users or the teams are the best ones to know what they want, right? They know what their teams actually needs, what are their requirements, their development requirements. So that must be configurable by default by the users. And of course, a dynamic product. So basically ensure that this product has the scalability characteristic enough to scale based on demand. So let me introduce you to Fleeting Runners, the solution that we have been working and developing so far. We are working on it for the last 2 years, and basically is a solution based on GitLab runners, okay, with the Fleet plugin. That is a plugin responsible to manage resources on a cloud provider. That's it's where it comes the Fleeting Runners name. By the book or by the documentation, if you check on GitLab, it's a very simple setup. So it has only two requirements. So a GitLab Runner Manager, that is a GitLab Runner with the Fleet plugin for the selected cloud provider installed on it, and executors. Executors is something like a virtual machine that must have installed on it three things: Git, GitLab Runner, and every or any tool that your team might need in order to accommodate or to run their workloads. For example, a compiler. So let me try to explain what this means in terms of base architecture. So our product is a Terraform module that basically abstracts all the infrastructure setup layer from the users. This all starts with a team project or a group inside GitLab that has the requirement of having a runner registered to it in order to run, of course, their pipeline definition. In our case, we trust on AWS as a cloud provider. There are fleeting plugins to other cloud providers such as Azure and Google Cloud Platform. And our solution works with Elastic Container Service in order to have a place or a service where we could put our runner managers running. So the main responsibility at this time of a runner manager is to register against a team, project, or group with a certain amount of tags and be up and ready and waiting for new jobs to be triggered. Once it receives a job or a pipeline triggered by the team on GitLab, it will start to interact with an auto-scaling group. And in that auto-scaling group, one or two, or it depends on your configuration, EC2 instance will be provisioned, what we can call as executors, in order to work or to handle with the workload that you have defined on your GitLab CI pipeline. And these two are configured using Terraform. So each team has its own runner setup, basically a Terraform repository where they can have all these definitions in order to set up or trigger or deploy their runner managers and executors. How many, you might ask? As many as the users want. So we need to accommodate different use cases. So they are the ones who can decide how many runner managers and how many executors need to be provisioned for their workloads. Another characteristic of the product that we had to have in mind was the possibility to be configurable. And if we remember, we talked about two requirements from the GitLab side, runner manager and the executor with
all the tools or software that might be needed to run your pipelines. Based on that, and assuming that all the executors are EC2 instance or virtual machines, we trust on Packer also from HashiCorp in order to be able to build our own AMIs, or the users to build their own or what we call custom AMIs, Amazon Machine Images, where they can build upfront some images with some tools on it already installed in order to improve their performance on their pipeline executions. Another architecture, so just to show you a little bit more about all the different components. So each render manager are responsible to manage a very specific auto-scaling group. This auto-scaling group refers to executors with a certain instance type, a certain operating system, a certain executor type. We have instance, we have local autoscaler, and you can even select between different system architecture like x86 or ARM-based machines, Ubuntu, Linux, Ubuntu, Windows. So it's up to them to define all these use cases, and this will give them the freedom to accommodate what they want, how they want, and we also provide them some storage capabilities. Some of them has some requirements in terms of storage capabilities. Nowadays, we provide them S3, TFS, and FSX in order to be able to mount some disks on their executors to improve their pipeline efficiency, in order to cache some dependencies or to store some data across the different runs. Alongside with this architecture and all this platform infrastructure, one thing that is also very important is to show them the healthiness of their setup. So once they set up anything, they want to make sure that what they have been set up is up and ready and healthy, and there are no issues. Based on that, we also provide them what we call monitoring out of the box. For this monitoring, we trust on Datadog to provide them and us some important data about the usage of the fleeting runners. Some information could be like what is the current manager version that they are using, how many jobs were executed during a time frame, or how many jobs are actually running at the moment, or how's the distribution of our runners across the different projects. Apart from this is like more administrative, let me call this way, more administrative data where we can see the usage of it. We also provide them some CI observability. So observability more focus on the CI and the performance of it. And once again, Datadog also provides, or we trust on Datadog to do that. More data or observability focus on pipelines executions, success rate, pipelines duration, in order to empower them to be able to identify any bottleneck, and they can use that information then to update or improve their runners configuration. Some more data. So we want to know, as developers of this platform, we want to know how our systems are being used and how much they are being used. So we also have some data to ourselves in order to identify like how many setups we have at the moment, how many projects we have onboarded, how many runners each one of the projects has set up, the distribution of all of them. More data really related with the cloud provider itself, like which is the most instance type used, how they are using the AMIs, because they have different ways to reference an AMI. What is the distribution of executors types? This is also this part of this information being used to check the system behavior and usage. It also helps us to lead the future developments and the roadmap ahead for our product. Some of our numbers, so these are numbers for the last year. This is data from the real usage of our product from our teams. We have an average of 350K of jobs being executed on Fleeting Wonders per month. Okay. We are talking about 1.5K of jobs duration per month. So 1.5 month each month. So accumulated time. Our current configuration or our clients' current configurations can lead up to 25K of jobs being executed parallelly. We also have a jobs peak or jobs load peak of 300K of jobs being executed at the same time. We are talking about more about cloud providers. So we are talking about around 36 AWS accounts being managed by us. And our users, like all the users combined, all the setups combined, they are asking or requiring. This is like the max value that they can require nowadays at this moment is 15K of vCPUs and 400 terabytes of memory, all the instance types and all the setups combined. We are talking around an expense of 350K of euros being spent every single month just in infrastructure for all the runners. Apart from these numbers for the Fleeting Runners product, we also have a much cheaper or easy to use approach or solution called Shared Runners. That is a Kubernetes-based solution to accommodate those kind of workloads that don't have any kind of special requirement, like some for example, all the lintings and those very simple jobs that don't require the necessity of having a fleeting runner setup. And we have around 1.5 million jobs being executed on that solution, a part of all the fleeting runner workloads. And this was my talk for today. I hope you really enjoyed. Let's talk about CI/CD setups at scale. Thank you so much for your attention. Bye bye.